Welcome to Nimo's World. It's me Nimesh Naik. Today I am discussing CSIR Net Questions June 2019. Topic Linear Algebra. It's a part B question. Question. Let V be the vector space of polynomials in the variable t of degree at most 2 over R. An inner product on V is defined by inner product f comma g is equal to integral 0 to 1 f of t into g of t dt for f comma g belongs to V. Let W is equal to span of 1 minus t square comma 1 plus t square and W perp be the orthogonal complement of W in V. Then which of the following condition is satisfied for all H belongs to W perp? So our option number 1 which says that H is an even function, that is H of t is equal to H of minus t. And option number 2, H is an odd function, that is H of t is equal to minus H of minus of t. And third option, H of t is equal to 0 has a real solution. And fourth option, H of 0 is equal to 0. So from this question we wanted to find a function H of t from W pub. So our aim is to find a function H of t from W pub, that is a general form of H of t. So in our question we have given that V be a vector space of polynomials in the variable t of degree at most 2 over R. That is, we can conclude that dimension of V is equal to 3. That is, dimension of V is equal to 3. And also we have given a standard inner product. Inner product f comma g is equal to integral 0 to 1 f of t into g of t dt. Now we have dimension of V is equal to 3, and also we have given W is equal to span of 1 minus t square comma 1 plus t square. So from this we can conclude that dimension of W is less than or equal to 2, and also we have seen that 1 minus t square and 1 plus t square are linearly independent. So we get the set 1 minus t square comma 1 plus t square is linearly independent and the dimension of W is less than or equal to 2. So from these two we can conclude that dimension of W is equal to 2. And also we know that W and W pub have no elements in common, that is W1 intersection W pub is equal to 0. So therefore we can conclude that W direct sum W pub is equal to V. So from this we can say that dimension of W plus dimension of W pub which is equal to dimension of V, and we also know that dimension of V is equal to 3, so which is equal to 3. And dimension of W is equal to 2 is substituted in the above equation. So we get 2 plus dimension W pub is equal to 3. From this we get dimension of W pub is equal to 3 minus 2 which is equal to 1. That is dimension of W pub is equal to 1. Therefore we can conclude that W pub is generated by a single element. That is, since we get a dimension of W pub is equal to 1, so for the basis of W pub containing a single element, so we can say that W pub is generated by a single element. That is, W pub is equal to set of all alpha into P of t, where P of t is a fixed element from V and alpha belongs to R. Okay, that is, W pub is spanned by a single element. And also we have W is equal to span of 1 minus t square comma 1 plus t square. But while computation using these two elements is much more difficult, so we rearrange W is equal to span of 1 comma t square. This is because by taking 1 minus t square and 1 plus t square. So W is containing all the linear combination of 1 minus t square and 1 plus t square. So using these two elements, we get the elements 1 and t square. So we conclude that W is equal to span of 1 comma t square. This can be changed because only of we want to easier for computation. So by taking 1 plus t square and 1 minus t square, so sum of that two elements 1 minus t square plus 1 plus t square is equal to 2. That is also belongs to W because the linear combination of basis element, and also it's a subspace, so there is scalar multiplication is possible. So 1 by 2 into 2, which is equal to 1, which is also belongs to W. So we get the basis element 1. And also taking minus of 1 minus t square plus 1 plus t square, which is equal to 2t square, and also 2t square belongs to W because is a linear combination of 1 minus t square and 1 plus t square. And by scalar multiplication 1 by 2 into 2t square, which is equal to t square, so which is t square also belongs to W. And also 1 and t square are linearly independent. We know that 1 is the easiest calculation. By checking, we can see that 1 and t square are linearly independent. So we take another basis for W, 1 and t square. That is, we conclude that W is generated by 1 and t square. Okay. Also we know that W purpose is spanned by a single element. So we write like this: W purpose equal to span of P of t, where P of t belongs to V, and the polynomial in V, which is of the form a naught plus a1t plus a2t square, that is W purpose equal to span of a naught plus a1t plus a2t square. And also every element in W is orthogonal with every element in W purpose. So by using this, we generate two equations, and by solving that two equations, we get the general form of a polynomial in W purpose. So for that, inner product of P of t comma 1 is equal to 0, which implies that we in question we have given that inner product of f of t g of t is equal to integral 0 to 1 f of t g of t into dt. So by using that, we get integral 0 to 1 a naught plus a1 t plus a2 t square into dt is equal to 0. So by simplifying, we get a naught plus a1 by 2 plus a2 by 3, which is equal to 0. So put it as equation number 2. And now we taking inner product of P of t comma t square, which is equal to integral 0 to 1 a naught plus a1 t plus a2 t square into t square dt is equal to 0. We where P of t is an element from W purpose, and the t square belongs to W. So we the inner product P of t comma t square is equal to 0. By solving this, we get a naught divided by 3 plus a1 divided by 4 plus a2 divided by 5 is equal to 0. Put it as equation number 3. So we get two equations. A naught plus a1 divided by 2 plus a2 divided by 3 is equal to 0, and a naught divided by 3 plus a1 divided by 4 plus a2 divided by 5 is equal to 0. So we get two equations where in three unknowns. Two equation in three unknowns, where a naught, a1, a2 are the unknowns. So we can conclude that there exists infinite number of solutions for this system of equations. So we take arbitrarily taking a value for a naught. So I take a naught is equal to 1. By substituting a naught is equal to 1 in these two equations, and simplifying, we get a1 is equal to minus 16 divided by 3, and a2 is equal to 5. And we know that W purpose equal to span of a naught plus a1 t plus a2 t square. So we substitute the values for a naught, a1 and a2, so which is equal to span of 1 minus 16 divided by 3 into t plus 5t square. That is, we get a W purpose equal to span of 1 minus 16 by 3 t plus 5t square. So we get every element in W perp, that is for all h belongs to W perp, which is of the form, that is h is equal to alpha into 1 minus 16 by 3 t plus 5t square. That is the general form of, that is we conclude that the general form of h is alpha into 1 minus 16 by 3 t into 5t square. If we put alpha is equal to 1, because alpha be any real number, so I taking alpha is equal to 1, we get h of t is equal to 1 minus 16 by 3t plus 5t square. That is, if we take him the value alpha is equal to 1, we get h of t is equal to 1 minus 16 by 3t plus 5t square. Next, our first option is says that h is an even function. And our second option says that h is an odd function. So we want to verify whether this function h of t is equal to 1 minus 16 by 3t plus 5t square is even or odd. So we first calculate h of minus t. So h of minus t is equal to 1 plus 16 by 3t plus 5t square, which is not is equal to h of t, and also we know that which is not is equal to minus h of t. Therefore we can conclude that h of t is neither 1 nor onto, h of t is neither even nor odd. So our first option is also wrong, and also our second option is also wrong. Now our fourth option says that h of 0 is equal to 0. So for verifying we have to calculate h of 0. In substituting t is equal to 0, we get h of 0 is equal to alpha. So this equal to 0 only if alpha is equal to 0. So by taking alpha is a non-zero real number, we get h of 0 is not is equal to 0. Therefore our fourth option, h of 0 is equal to 0, is a wrong statement. So we can say that our third option, h of t is equal to 0, has a real solution, is the correct option. For verifying that, we just calculating root of b square minus 4ac. That is, we are verifying whether h of t has a real solution or not. By calculating root of b square minus 4ac, which is equal to root of 256 alpha square minus 60 alpha square, which is equal to alpha into root of 196, which is greater than 0. Therefore we get b square minus root of b square minus 4ac is greater than 0. Therefore h of t has a real solution. So our third option is the correct one, and the remaining options are false. Okay, thank you. If you like my video, please subscribe my channel and also share with your friends and like.